Keys are becoming a thing of the past. Today, we're going to build a smart, secure door lock using an ESP32 and just a few simple components. Imagine this, you get home late and you have forgotten your keys. Instead of waiting or calling for help, you just enter your PIN and you're in. This project gives you that kind of control and convenience. This is the ESP32, our microcontroller. It controls components and runs the code for the lock system. This 4x4 matrix keypad is how you will enter your access code. It's responsive and easy to interface with the ESP32. The servo motor controls the lock mechanism. We'll program it to rotate and unlock the door when the right pin is entered. This is the OLED display that shows real-time feedback. In this setup, we want to test our keypad with the microcontroller. So to achieve that, we'll be displaying the readings of the keypad on the serial monitor to see if every button is functional. So I'll do the connection, and you can see that is done. We'll skip this first one and connect it from the second, like that, and we're done. So our setup is complete. All you need to do is to code with the right firmware, and we'll see all the buttons in action. So let's get started with this simple line of code. So copy the code that is provided in the description and transfer it to Arduino Cloud. You can mount your ESP32 board and select it so that we can program it later on. Our board is ESP32 S2 dev module. So line 1, we are starting by including the keypad library. You will need to include this keypad library, and on the Arduino Cloud you can click on libraries here and you can search for it, keypad. A better method is to download this keypad library. Just click here and download, and then you can upload it from this option here. So when you click on it, mine was already downloaded. It will direct you to your PC so that you can select that particular library. So for me, I can search for keypad, and you can see we have the keypad already installed, but you can try once again, and you see it says the library already exists. So that's how you normally include a library as a zip file. Then we'll explain the code from line 3 to 4. Here we define constants. This tells the code that our keypad has 4 rows and 4 columns, giving us a total of 16 keys to work with. Line 6 to 10. Here is where we map the keys on our keypad. So let's go on to line 13 to 14. Now we define which GPIO pins are connected to the rows and columns of the keypad. Then let's go to line 16. So here we create a keypad object. This line connects our keypad map and pin definition to the keypad library, so it can start listening for key presses. And then we have the void setup function. This void setup function is used to define the baud rate. And then finally we have the void loop. So this part constantly checks if any key is pressed. If a key is pressed, it prints the key's value to the serial monitor. Now you can proceed to program your microcontroller. I've already programmed mine. So after programming, you can go to serial monitor on your top right corner, and the serial monitor will appear. So it's already connected. Remember, our baud rate was 115 to 100. So you can see my hardware setup is already there. So we can start pressing random keys. Let's go with 1, 2, 3, 4, 5, 6, 7, 8, 9, and you can see the outputs on the serial monitor. Next, we link the keypad input to a servo motor. Once the correct pin is entered and hash is pressed, the servo unlocks the door briefly before locking again. So the servo motor normally goes to pin 20 on our ESP32 board. So here is pin 20. So I'll connect the signal pin to pin 20, ground to ground, and I'll give it a 5-volt current. So the next step is to program the microcontroller and see how after every correct password input, the servo motor will be rotating. So we want to program our ESP32 microcontroller by interfacing a keypad and a servo motor. So for this setup, we'll need two libraries, that is line 1 and 2. We already included the keypad library, so we need also to include the ESP32 servo library that will enable us to work with the servo motor. So make sure that you include the two libraries in order to get started. So we'll continue to explain the code. So in line 4 to 5, we are defining the constants. We define the pin that the servo is connected to, and that is pin 20 in our case. And afterwards, we create a servo object that will control our door. Then we'll proceed to pin 7 to 8. Here we define the correct pin, which is 7890. We also initialize an empty string to store the user's input as they press the keys. Let's proceed to the void setup. In the void setup, we set the baud rate for debugging purposes. We also attach the servo to the pin and set the servo to 0 degrees, means that the door will be initially closed. So finally, we'll go to the loop function. We continuously check if a key has been pressed on the keypad. And for that, we'll have 3 possible actions. Action number 1 is if the user presses the hash key, means the user has finished entering their pin. Therefore, if the pin is correct, we print access granted, rotate the servo to 90 degrees to open the door, then we wait for 3 seconds and then it closes. And if the pin is wrong, we print wrong pin and reset the input. The second option is if the user presses star. This acts as a reset button, clearing any current input in case the user made a mistake. And then finally, the other option is when a user presses any other key. So every other key press gets added to the input password. We also print it out so the user sees what they have typed so far, just like a digital lock display. Now we have the microcontroller programmed with the firmware and it's powered on. So let's see what happens if I put in the wrong password. So I'll put a password of 5870 and submit it with a hash. So definitely that's the wrong password and there's no movement from the servo. So let us try a different password. We'll go with 7890, which is the right password, and make a submission. Notice the keypad moved an angle of 90 degrees and after a small delay it closed. Finally, we'll add an OLED screen to the setup. This is just for the user communication, such that When they are given access, it will be displayed on the OLED screen and vice versa. So on the pin configuration file, it's defined that the OLED screen should go on these particular pins: 3 volts, ground, SCL and SDA, which is actually written on the OLED itself. So I'll do the quick connection. So just like that, our OLED screen is connected. So let us proceed to program the microcontroller and see what will happen. Now we have the entire system set. So what we can do, we can try to put in a password. So let me give it 5860 and see what happens. So we can put the right password. And it says access OK. And you can hear the servo rotated at 90 degrees and then it shut. That wraps up this episode. Great job getting your smart lock door system up and running. Up next, we'll dive into the IoT platform setup, where we connect the ESP32 to the Boonie IoT platform. This is what lets your device talk to the internet and respond in real time. Don't miss it. See you in the next video.